Swayam Prabha. Digital India. Educated India.
It involves situations where the potential outcomes and their probabilities can be known. You can predict. That's the big difference. The uncertainty, the outcomes are unknown. What's going to happen because of an uncertainty? Whereas, what are the risks behind that uncertainty? And can you predict those risks? Yes, you can. The probabilities you can predict today with the data. So that's the big difference between uncertainty and risk. So risk can be quantified, uncertainty cannot be quantified. So everybody with me? Anybody has any comments or debate on that? So when we say demand uncertainty, we don't know how much the customer is going to order ahead of time. But when we say the probability of a risk of a particular event happening, then based on historical data, you can predict that kind of a, what is the probability? High probability, low probability, at least you can look at it. So once you know the probability, you could quantify the risk a little bit in terms of what will be the impact, right? If there is an impact, let's say the probability of an event, whatever that event is say 20%. The impact is you're going to lose, say, $100 or 100 rupees. Then the expected loss is the probability times the actual loss, is the expected loss. So that kind of a quantification can be done in order to categorize the risks for us to do the mitigation. Whereas uncertainty is more characteristic of so many things that it's difficult to measure it. So it's difficult to have a quantification because of the measures. That's, I would say, the biggest difference between uncertainty and risk is. Okay? Yes, please go ahead.
Sir, when the experts are not able to express the decisions, so generally we assign a number there. We generally say uncertainty in decision. Why don't we say risk in the decision?
Because we are not able to quantify. If you are able to quantify those risks, then you would go with the risks. Again, that's what it is.
Okay.
So anything that you are trying to look at as variables that affect, can you quantify them? Fuzziness is used for things that you cannot quantify. Right? For example, tolerance to pain. Tolerance to pain. Imagine that and trying to quantify human tolerance to pain. In medical terms, if you want to quantify that, that's very difficult. For the same scenario, your tolerance and my tolerance would be very different. Agreed? So we could only be fuzzy in quantifying. That's why we are not calling it as a risk that can be measured, because the value for you and the value for me are very different. Interventions are based on our tolerance, right? Even, any kind of intervention that you see is based on the tolerance. So that is an example as to how we cannot put a value and say it's going to be the same for you and for me. Okay. It's uncertain between the two of us, difficult to quantify, but we have methodologies like fuzzy theory to some extent represent both our risks. So on a continuum, you would say you are low pain tolerance, I'm high pain tolerance. And kind of see what interventions are needed for a low and high pain. So that's how we look at fuzzy kind of a logic. Yes, please. Take the mic, please, so that. Why did my best student go back?
Good morning, sir. Sorry. I will come forward.
Go ahead. Sorry, I was just kidding. Yeah.
Sir, my question is, we have bullwhip effect. Bullwhip effect.
Yes, please.
So it says that exaggeration in demand from the different demand centers. So here, what we should understand? Should we understand it uncertainty in demand or risk of exaggeration?
I think the bullwhip to some extent has the kind of reasons that we could define it more through risk, because it repeats. Uncertainty is an area is something that doesn't repeat itself. The risk here is a forecast error.
Yes.
Could cause the bullwhip. Right. So
Just because we have some nodes known to us that whatever exaggeration will come from that point only.
Yes.
That's the demarcation.
information about the node can be quantified.
Yes. Understood.
If that's the case, we fall more into the risk category and not into the uncertainty category.
We generally give some numbers, quantify. There are membership function, membership and non-membership function. That tells the probability only like 20% this is going to happen. So we generally say it uncertainty in the judgment for the membership function is 20% kind of thing. So how come, sir, means how they, is it appropriate to say this is uncertainty, or we can as a,
Only because it's a range, we call it an uncertainty.
okay.
In the fuzziness, since it's a range, if we do not have one point, like saying it's a 20% risk for all of us, there is an uncertainty only because of the range. And that's why it falls more into the uncertainty. Okay?
Okay, thank you, sir.
Alrighty, let's move on after that. Today, it's an important one. We're going to talk about AI in our healthcare operations and supply chain management. So I'm going to bring home a lot of things we've been talking in the last 4 days about the complexity type of things in healthcare, then bring it down to supply chain level and see what are the actual tools and how can they be applied. Our idea of today's lecture is to again look at about 5,000 feet level on AI as a field and how it can help, not come down to the 100 feet level and say, here is a technique and I'm going to teach you the technique. That's not the purpose of this. So don't be disappointed if you do not walk away knowing how to code. We are not a coding session here. So AI and machine learning for healthcare operations, supply chain management, both the global perspectives and also a lot is happening in this part of the world. The data and information in India in this particular domain is tremendous. So you may want to keep up with this and then take it with you and see how to explore some of the things which are highly local. So I'm going to talk about it in a very structured fashion. We're going to do some introduction and context settings, then give some core concepts, then applications in healthcare supply chain management, then applications in the Indian healthcare supply chain management. What are some of the challenges, limitations, and do not forget, please, the moment AI comes in, there are ethical issues. It automatically introduces a lot of biases. So even if there are biases already, they can get exaggerated if you don't handle that properly. So it's important to understand the ethical issues. Then we'll kind of do an in-class exercise where you will be managers deciding for your organization, if you are implementing AI, how would you do that? So that we will do that as a team exercise and then wrap up. So that's what we want to do today. So the question is asked, right? Like anywhere, anything else, today's question is, why AI? Why this machine learning? We'll describe those two things a little later to give the context. But in general, right? Well, if things are simple, it's easy to decide. Last night went home because of the birthday, the family wanted to decide where to go to eat. I thought it's a very simple decision. You asked me, I am very allergic to a few things, but it became a very complex decision of who's, anyway. So even if simple things to where to eat becomes complex, I'm sure you will appreciate with me that healthcare is extremely complex. And we'll talk about a few nature of the complexity in a minute. So that's one, right? So we've been talking about this last 4 days. Healthcare is not a simple thing because of the number of stakeholders, number of issues, technology, all those kind of things. But at the same time, there's nowhere as important as it is in the healthcare, especially supply chain, for precision. Because wrong decisions can lead to erroneous and bad outcomes. not only precision, which means what is my inventory level, as much precision can I have in that, speed with which you do, because of the lives you affect, you cannot wait. You saw what happened the very first day we started by looking at that simple hospital system and that simple valve that was not available, and what do we call that? Ripple effect. The ripple effect is what we started off, the whole course. So that needs the speed with which you coordinate things. But at the same time, healthcare is one thing where countries are spending a lot, but the outcomes sometimes don't match what is being spent. So what is this cost perspective, and how do you optimize? At least you could use the word optimize. You should not use the word optimize when you're talking about people's personal lives and health, but it is optimize when you're talking about materials and things that you bring to do that. Can you optimize with respect to supply chain management? So those are three critical ones. And if you look at now, bring it to our system here in India, like many places, but this is a much more heterogeneous kind of a system you have within population and spread and where they live and east, west, north. It's so difficult to put a finger and say one right manner will work everywhere. So that's going to be another one. And then something has happened post-COVID, whether we knew it or not, whether we liked it or not, the digitization started happening more than because of we could not go in person and do things. We moved things online. So that created this digitization speed that is unnerving. But now that we have created it, we are looking at data. So it behooves the question, can we use techniques like AI on them? So that's another reason. And then we have become very global. All countries are global today. There's no country that I visited a lot of them. Even if they're small country, they're poor country, still they have a global kind of visibility because of something they do. Went to Ghana, cocoa, the number one export in Ghana. So every place is globally visible to the world for trade and other things, but they all have so much local constraints. I talked about the healthcare ministry making even decisions on who can administer the vaccine in rural areas. Things like that are constraints that still keeps us awake, saying, how do you create this effectiveness in delivering this healthcare, and especially in supply chain? So those are some of the things why this area of AI and machine learning becomes a nice fertile area to apply because of the data that we are getting. Stop me anywhere if you have a question with this. So the next few slides I want to spend on the complexity. I want to bring that home to you all, what's complex nature of healthcare supply chains. So multi-tiered, multi-stakeholder systems, right? So what are the multi-stakeholders? You've got hospitals, you've got pharma manufacturers, you've got distributors, you've got suppliers of medical devices, you've got diagnostic labs, you've got insurance providers, you've got government agencies, you've got public health bodies. My goodness, you don't see so many to provide a service or a value to a customer in other type of industries, if you can think about. These are disparate kind of groups. They all have different objectives. They may have the same goal of caring for somebody's life and making the wellness an option, but the way they come at it and the financial constraints each one of them have, private versus non-private. So all those kind of things makes it even more complex in that sense. Now, that's with regards to people and who they are as stakeholders. Come down to the products. We have an industry, healthcare, where the products have a life cycle, have perishability attached to it, especially the things like vaccines, blood products, certain drugs. So we have to look at storage, we have to look at transportation, and we have to look at their inventory constantly because of the shelf life, as opposed to something that you can store for years and not worry about it because of the perishability issue. Now, demand unpredictability. And I want to put this into two categories, right, based on what we have discussed in the past 3-4 days. One is there are certain kind of services that you provide where the demand could be predictable. You know how many patients are going to come to receive your routine care, checks and things like that. a diagnostic lab might be able to do that patient population. But then you have outbreaks. The outbreaks, I mean, we know about the huge outbreak that we had, but what about the short-term outbreaks that happen, malaria, dengue, and all those kind of things, which are sometimes seasonal. And then every time it doesn't spike the same way because of the interventions, it could spike very differently. So that creates the uncertainty in the demand. The demand predictability becomes very difficult to forecast with traditional methods. And so that's another reason why the complexity increases. Then you have an industry where we have a regulatory body. Whether we like it or not, it is important because it involves patient safety. So the regulatory oversight has compliance with safety standards. So it's not like, you have to do something, but you have to do it with, I'm just coming in the last 4 days, like professor with your 20 kilometers per hour. And the compliance is ensured by every 10 feet somebody is standing and waving you. Okay, I could see the frustration in my driver sometimes, but I keep telling him, okay, that's fine. And the other day we saw a deer cross by and I said, okay, this is the reason. The safety is not, something of a pie in the sky kind of a thing. So the regulatory oversight, which in this case, in our industry that we are looking at as cold chain products and protocols and drug traceability regulations, some recalls and whatnot. So the system becomes a little rigid. Every time you put regulations, you don't have what you called the other day the flexibility. That's kind of constrained sometimes, and but it's essential because of the safety. Then the criticality of availability. I mean, if you go to buy a product and the product is not on the shelf, you may get frustrated. You may go to a different shop, but the criticality of availability is not end of life for you. But in healthcare, it could be. So shortages can directly affect a patient outcomes, while overstocking, again, because of the perishability nature of some of the products or the time nature of products, could lead to wastages and higher costs to dispose them and so on and so forth. Then we go back to number one, and then the last one is related highly fragmented providers, because you have a different same service provided by people with different goals, right? The corporate hospitals versus small clinics versus public sector. So that is again interesting. You don't see a car manufacturer saying, let me sell a few through a public outlet and a few through a private. I mean, you see that homogeneity. Good or bad is not the question. You see a homogeneity, you see a heterogeneity. Heterogeneity in any system increases its complexity to manage it. Thoughts, comments on this particular slide, please. Please go ahead. The mic is at the back if you want to use it. Out.
Public sector hospitals and corporate hospitals, why is it not fragmented?
No. This one is universal. This slide is not for India. Not only for India. This slide is very universal. I mean, the US has the same kind of complexity, right? As a matter of fact, it becomes even more when you have a 100% insurance-based healthcare, because the insurance itself plays out differently whether you go to a public hospital versus when you go to the private hospital, right? Because the policies there changes. Who's supporting you? Medicare, Medicaid, and all those kind of things, insurance companies. So yeah, it is as complex. You got community hospitals, you have non-profit NGOs, so it plays out very similarly in multiple countries. The complexity here is probably much, much more in terms of that heterogeneity, population mix and things of that kind. So that's first. So we said, why do you think AI and ML are good? The complexity. Number two, we talked about is this precision, speed, and cost optimization. Let's look at that a little bit more in detail. So precision, obviously, right medicine, right device to the right patient at the right time, right place. I remember I was a little frustrated. 3-4 days, my heart was not pacing. And finally, they decided on a particular day, I'm going to get a pacemaker. But I didn't realize that the stretcher that comes to take you to the pacemaker has to fit certain regulatory requirements. So I'm waiting in my ICU, ready to go. In came the stretcher with the people. They've already given me instruction to move and get into this because I had other devices attached to me. As I am getting up, somebody says, oops, the wrong stretcher has come. And then I went back to there. So the precision in terms of even the simple things. And it was, you may smile, it had a ripple effect. Oh, something happened? Okay, I didn't even realize. Did I move anything? Oh, maybe I moved away. This one? Sorry, I am the culprit. Sorry. I get excited when I talk. So the precision, the right medicine or the device to the right patient at the right time and the right place is critical. As precision-wise. Speed, you're talking about faster replenishment cycles, the real-time response to fluctuating needs. Again, going back, if I bore you with my example, that's the only example I can give you where I can be honest about what happened because I saw it with my own eyes. So the particular day that the pacemaker thing was happening, I get a nurse assigned to my ICU bed separately. I mean, and I always like to see the same person. It comforts you, right? So that person knows you, you know that person, kind of a thing. So first 3 days, I had the same person. On the day that I was supposed to get, in the morning, I'm awaiting that person to come, and in comes another person. And there was some kind of reassignment that had to happen because of some crisis. The department, a few people didn't show up and things. So my the one that was attending to me was reassigned something. It went to another ripple effect. This person was not experienced with the ICU. They had to be deployed from somewhere else. So even an insertion that the other one was like, did it easily, took about 3 or 4 pokes before the new one did it. So things like that in terms of response to fluctuating needs is becomes interesting. The other one is cost optimization. Because cost is where you could look at, can I deliver the healthcare in an affordable way to the population, right? If the cost is too high, then it becomes very difficult. For example, to give you an idea, when we were in Ghana, the Ministry of Health told us that their budgets have been exhausted to get more vaccines. We got an information one day saying a government of a country telling us that the budgets, healthcare budgets, have been exhausted to place orders. So one of our roles was to go get loans from the World Bank in order to help, procure the vaccines. So things like that. I'm not blaming them, but I'm saying cost is a big issue and how you manage it to manage your financial well-being, which means reducing inventory costs, transportation inefficiencies, and spoilage from our perspective from supply chain. There are other issues, but for us, which if you better visibility across supply nodes reduces both overstock and, if you know what is where, that itself is half the battle won. Then you have financial pressures in this part of the world, right? I'm told, I don't know the accuracy, Professor, on this particular statement, it says 60% plus of all healthcare expenditures is still out of pocket in India. So making efficiency not just a business issue, but a social one. If that's true, which is true, right? So some extent. So need for precision, need for speed, need for cost optimization. So if you can apply an AI ML model to kind of give you options on how to achieve this, why not, is the question. And you talked about this, and I threw in a few things here. Highly heterogeneous, right? So public sector, central and state-run schemes, there are some schemes that have been given there. Massive rural-urban divide in infrastructure and logistics, obviously. That's in the public sector itself. The private sector ranges from large hospital chains to small clinics. So the cost structures vary accordingly. I'll talk about it. I've got another slide that talks about private diagnostics labs. Also have complex supply chains, and wait for the next slide that kind of explains that. Then pharma manufacturing and exports, the global leader in pharmacy of the world, but the active ingredients are still being imported. Okay? So that's critical, because you are dependent on the rest of the world to send something so that you could value add, send it back. So the pharma world is that way. Yes, please.
Yeah.
I don't know the data on that. Probably true. Not necessarily, but probably.
Like
research. More research, because these APIs come through active process ingredients. Research labs are the ones that discover. There's a discovery process to the APIs. So you have it in some of the ready labs and things like that kind. But with the scale that which you need to produce drugs to export, internal generation alone is not enough. It's a portfolio kind of an approach here on the APIs. And then certain types of APIs, not everything comes from China. It comes from advanced research labs also. And so those are needed to keep ahead, to spring forward with some kind of drugs. So that's also. And the export logistics, because you are now exporting to the rest of the world medicine, adds another layer of supply chain complexity, which I have a slide. I'll talk about that also. So then you have the digital infrastructure challenges. This is not true only to India, but it is a little bit more in India, is inconsistent electronic medical record adoptions. Inconsistent, not non-availability, but inconsistent. How it is used. And people who are here from CMC can tell us, in electronic medical record, what role do they play when the patient comes in? Anybody has any thoughts on it?
Good morning, everyone. So this is Alfred again, from CMC. So I did my UG in medical records, so I suppose I have better understanding. So EMR, we shifted the paper records into EMR last 10 years back. So basically the EMR, it works in two ways. We write in a paper and we scan it, and it will be uploaded in the software through scanning. The other way is that we directly enter into now the system is we have directly entering. So only OP services, mostly we're doing complete EMR. But then IP we are working on, but still there are practical issues there, because a lot of technical staffs are there and a lot of papers are there. So to digitalize this, it's being a very challenging, and because we are a huge institute of having almost 3,500 beds. So as Sir said, adoption is inconsistent.
It is not a criticism, it's a reality. That's what I want to tell you. Because of the patient population that you deal with at CMC too. So it's not a luxury hospital. It's got a lot of people who travel a lot of miles, wait there to get services. And what is important is to provide services, not to worry about whether their electronic record has been maintained. And there are enough other ways of maintaining it. So I'm not critiquing it. I'm just saying, if you want to use the type of tools, then the inconsistency creates a little bit of inefficiency in how we can use it. So that's my point here. And it's also because of that limited interoperability between private and public data systems. So if somebody gets serviced in two places, there is no sharing of data. So that also happens a lot. So all these are addressed, and I have a slide on the ABDM, the Ayushman Bharat Digital Mission. So it's a very, very, very ambitious type of a system if it comes to fruition. But again, it takes a while. So we had one of the slides that talked about why private diagnostic labs have complex supply chains. I mean, diagnostic labs get patients in, do a blood test or something and send them away. So why should it be so complex? Labs like ThyroCare or Dr. Lal Path Labs or SRL Diagnostics operate across vast geographies. So that creates the first level of complexity. Language. So the geography here relates to language right away. Handle high sample volumes. Data shows that Indian volumes are at least 100 times more than US, volume-wise. Understandable. So that has an impact. So they require intricate supply chain systems to ensure timely, accurate, and cost-effective diagnostic services. So that also makes it difficult. Key elements of the diagnostic lab supply chains: multi-tiered collection and distribution networks, right? So where you collect the blood, where you process that, all those types of things are. The sample collection points. These labs have thousands of collection centers. They also have franchised these things. They give it to others, third party, to go and collect. So that has to be trained. Partner hospitals spread across cities, towns, rural areas. That increases the complexity. There's an example for ThyroCare that does that. Then they have a very hub and spoke model that you see there as a small diagram that has been illustrated. So various hubs are the regional labs that collects, and then sending it to other collection centers that send it to the regional labs, and then they go to the centralized labs to be processed. So all these things creates logistics issues that need to be managed, increasing the complexity. So once it's collected, then you have logistics and transportation, which is time sensitive. Any of these cannot be stored for a long period of time. So air cargo, dedicated courier networks, even drone deliveries to reduce turnaround times and reach remote areas. All these, Professor talked the other day about drones. It's becoming more and more an important asset to look at, and if that is the case, for the type of research the professor talked about. Temperature control is important. Many samples require cold chain logistics with dry ice and temperatures monitoring to prevent spoilage during the transit. Then technology and automation. A lot of these labs employ very advanced IT systems for tracking, barcoding, real-time monitoring of samples, ensuring traceability and minimizing errors. So it becomes very critical. A lot of automation is also there in these labs. Look at that particular diagram that talks about from when the sample is received to report generated after analysis. Things move like an assembly line, automated at every stage. And then digital platforms, e-portals for materials requisition. So you have the physical side that you looked at, which is complex. Complexity is what? Number of elements interacting, which is on the physical side. Complexity is also number of informational elements that need to be managed. So both exist in this particular kind of just a lab, diagnostic lab type of situation. So I just wanted to put that there for you to appreciate that complexity is not only in large hospital kind of systems, even in these lab type of settings, you could see that. And then inventory and vendor management. So the labs have to order reagents and consumables. So they have to look at steady supply of reagents, chemicals and consumables, many of which might be imported because all might not be available. And that creates its own, import-export type of thing. So managing inventory, forecasting demand, ensuring compliance with regulatory standards adds that complexity. Vendor relationship, anytime you are ordering these things, vendor relationship becomes, and how do you do that? Then, of course, the regulatory and quality compliance, national and international quality standards, and real-time quality monitoring, regular audits. Regular audits means cost. We are talking about optimizing cost, and then we are talking about regular audits, which is going to add to the cost. So this constant tussle, once IIT decided, I'm going to take care of the deers or the speed, they have to invest a cost. People standing and asking people, so it's a cost. Then you have data security and traceability, which is patient data for every sample. That's so critical. Okay. The other thing on export logistics, anything that you do to export after you manufacture or do also goes through similar. I'm not going to spend too much time, but again, they have similar type of things: regulatory compliance, temperature, more complex transit routes, customs and border procedures, visibility and tracking challenges, risk of counterfeiting and pilferage. So all this happens as things get out of your hand and you're handing over things as they leave the borders, as they go to other parts of the world. So you need, for these kind of things, you're talking about specialized expertise. Not anybody can just walk in and say, let me take care of export. So today, the specialized expertise is coming through an AI chatbot that's built at least to train somebody, if not replace somebody, so that people get up to speed quickly, or people chat to ask specific questions, right? So that's becoming, of course, infrastructure and technology are needed.
Exported by India to Africa. So what was the issue there in this, if we look at it?
There was a quality control issue on a particular content in the medicine that was on the higher side. This is what I was, my knowledge serves right. So, I want to be careful in commenting. No companies that is exporting wants to behave in a rogue manner, like make money by doing this. Sometimes errors happen in labs. Batch of products might come in with the quality control not properly done or whatever it is. So they are going through the tracing and tracking and to see how to fix it. Problem is, product like this is not something you go to the field and say, let me fix it there. It's already consumed, it has impacts. What's the number one thing that happens? Trust. Immediately these things have happened. The trust with the manufacturer, the trust with the source takes a big beating. So I'm not going to again spend too much time on this. I was impressed, at least what this is intending to do, right? Because now we are talking about how do you collect data. Remember yesterday we talked about macro, meso, micro level. This is the most macro that you can think about happening at the country level, which is a digital health, which has at least 4 very interesting core components to it. One is at the individual patient level, like an Aadhaar card, I believe, kind of a thing, but with relationship to health. Then you have health professional registry, which is a centralized database to verify healthcare professionals, different doctors, nurses, and things of that kind. Then health facility registry, which is to look at the facilities themselves, hospitals, clinics, labs, making it easy for patients to find and access services, kind of a thing. And then the drug registry to look at all the pharma-related information. This is amazing. If you could go through and set up all these things, and if they could even work and talk to each other, that would be amazing. But we know that there are some challenges and issues. But this is at the most macro that I've seen. Because in the US, this is driven by the market, right? It comes micro to up. Some hospital will implement it. becomes a big standard. Other hospitals kind of try to emulate that kind of a thing, and that's how it propagates. And the market drives, it comes that way. Whereas the government drives, it has to be the other way, which has a little bit more challenges. They are talking about interoperability, digital health records, more inclusivity because all citizens should be included, integration with existing apps, enhanced privacy and security. So these are at least the features and goals. Anybody has any interaction with any of these? Anybody has any more information on what the ABDM or the Ayushman Bharat?
The uptake among the patients is very low. Sometimes some patients are, the frontline staff tells the patient that agar aapko treatment chahiye, you have to get this, you have to fill this. And since they don't have a choice, they fill it up. And a form is given, they fill up their details and the Abha ID is created. But in practice, how much it is actually used to take information of the patients currently, at this point, I'm not sure.
This interoperability is interesting. And if done well, is useful. So when I went through it, I found out that I'm allergic to one particular penicillin. And so now that information is captured and shared across through my EMR. So the other day I was with the dentist, completely different. And they would always provide me the day before the digital record of a dental record. And they have some screening questions. And some of them were already filled. And my new penicillin allergy was filled already. And so I was thinking, wow, the interoperability or the, talking to each other kind of thing helps. And they give me the thing to change if I have to change or, something has to be updated. But that type of thing is what I'm talking about. And because of my, cardiovascular surgery, every dental appointment needs a specific antibiotic. So that automatically now the people that are doing the scheduling would able to reach out to me. Not just reach out to me, reach out to my pharmacy to send that because it is a little potent in terms of the antibiotic medicine. They would not issue more than 2 per issuance. So all this regulatory compliance is also, so the pharmacy, when I go, has exactly 2 units. One hour prior to the dental procedure or dental appointment, and then one after the dental appointment. So it is helpful to see that kind of a interaction of information, but it takes a long time, and the heterogeneity makes it even more difficult than the homogeneity pop. But they say that the statistics looks pretty staggering that I looked at. This is as of February 2025. I'll let you read.
Visiting the hospital for any reason, I had like first-hand experience with me. The AVA ID has to be created for that. I visited not for any medical complications. I visited just for a medical checkup, like medical certification to I had to join a form. So they given just to medical fitment certification. That ID must have to be created, and it's mandatory now. Wherever you are going to get, how efficiently they are doing, it's the question, but it has to be done by the professionals who are sitting there, not by the patient, because they are not aware about the flow, but they are there. And it helps in propagation, how initiation of some disease also. At this age I was fit and fine. Next time whenever I am visiting, it's linked with the Aadhaar number, which is unique. So they can see how with age or with progression, how the new diseases are coming, or how in my own body if something is happening, so there is a very good information or statistics would be coming in future if we implement it. I am totally agree with you. Heterogeneity is like it's at its extreme, so it will take time, but it's happening. Thank you.
Thank you. So, we painted the picture, overall picture on complexity so far to see why or how the healthcare system lends itself towards the application of AI ML. But that by itself is not going to justify. Something else should have happened, which is the post-COVID-19 digital acceleration. So that you saw was necessity because of all the things that happened. So real-time dashboards have stopped, predictive analytics have been deployed, vaccine cold chain has been digitized, AI models have been built, ICU bed availability. So all those things needed us to look at data and see what happens. So it has increased the openness to the AI ML solutions. Then adoption of AI-based diagnostic tools. I mean, today, more and more you see, before the doctors look at data, it might be going through a process step to provide certain, at least categorization, to make it easier for them to look at. Tech-enabled healthcare platforms, you talked about this. Greater private-public partnership emerging in healthcare supply chain management. So, a lot of tech startups are happening. I think I'm meeting next week with people in logistics in general here that are startups. I have seen a few in the US. My own student has started a couple of things in the AI diagnostics domain for healthcare. So more and more I would encourage you all as the next generation, don't be employed, be the employers. That's the goal I want to give you. So I am not totally familiar with a lot of these things. I've seen some of them. I saw Healthify Me. I've gone through that remote monitoring type of thing. Logi Next is something I've been a little bit familiar with. Supply chain optimization. Some of these deal with patient health directly. Some deal with more material management type of systems. So be careful when you look at these, which one you're looking at. Anybody has any idea of any of these if you had interacted with them? Okay, talk about it. We're talking about Niramai.
Niramai is where they used AI tools to for mammography. So they already had a database collected, and based on which
Somebody's image comes.
and the report is automatically generated. But at what I'm aware is they were still trying to validate the tool, because that minimum amount that they would require to validate. And the clinicians, some of them were not accepting it. Like, I'm not sure, but they have some BIRAT score or something, and where they compare it with that. I'm not aware of this technical.
Anybody else? Any of the other softwares or anything mentioned or not mentioned, but you might know about? Which one, please? Covin? For what reason, my friend? Registration and records. Okay, Covin. Oxygen demand. Okay.
It's for this startup. Everything is that.
Okay. Okay. So how many oxygen cylinders are available? What condition, kind of a thing? Or when you say oxygen demand, how many patients need it?
You know what? You got that list. That. Right.
Plant was built. Increased.
Sir, I will add, I would add Practo and M-Fine. These are the apps for online consultation with the doctors.
Telemedicine, practice, M-Fine. Okay.
Yes, sir. These are online platform for consult with the doctor, where verified doctors are there based on experience, how much they have treated other patient, and based on their review, you can select, and the price would be based on the duration you will interact. So without physically you going there, you can take the some instruction from here only.
So I go into say M-Fine, I go through some search process and then I locate.
Yes, sir.
Can I go visit them telemedicine wise, or does it only suggest them?
Sir, it is based on your what type of disease you have. Yes, sir. Suppose you have a fever or something, you have blood report, you can directly consult with them.
Okay.
Yes, it's
Interesting. Thank you. Thank you. Okay. So we have validation here that has happened, that post-COVID-19 digital acceleration has led to. So you all verified, you have state-of-the-art kind of things, but face a few things that are challenges: infrastructure, poor rural connectivity, limited IoT penetration, data quality issues, fragmented, unstructured, incomplete data sets, workforce readiness. These kind of seminars are good, but they are a starting point, not the ending point. Shortage of trained data scientists familiar with healthcare domain knowledge, which is a global phenomenon, not just Indian phenomenon. The number of people who can help implement these things, and mostly in the public kind of domain, not in the private sector. Affordability constraints. Some of these are still expensive. Some of these are startups. As the gentleman said, some of these have not been verified yet. Number of samples and things of that kind. So those things also matter. Okay. So I've hopefully made a case that it's not a bad place to try out AI ML tools. So next we will spend time to define what those tools are and see how you can apply it to healthcare supply chain management, and then talk about the challenges and opportunities and ethics kind of things. So that's what we'll do now. So let's define AI. Refers to computer systems, obviously, that can perform tasks typically requiring human intelligence. And let's define intelligence very carefully. Reasoning, decision-making, perception, and language understanding. Those are the four things today computer programs and algorithms are able to mimic to some extent, right? Now let's put it in healthcare supply chain management context. What we have seen so far are AI-based chatbots for supplier coordination. So very domain-specific kind of a thing, where you collect that knowledge. You may have a call center operator, or you may have somebody to answer them in the past. Now you say, can you put on a chatbot? Decision support systems, which have been there for a while, but have become a little bit more intelligent now for procurement. What's the intelligence? Something may suggest there's an alternate source. Do you want to look at an alternate source? Previously, they would only do 0, 1. Yes, you have this. No, you don't have that kind of a thing. Intelligent automation of purchase orders. Again, purchase orders automatically routing itself, or even purchase orders that are negotiating price to days of payment. So that the vendor might say, if you pay me in 30 days, I'll give you this price. So that kind of intelligent negotiation in the pricing is now happening through automation, not personal negotiations. Image-based AI for package quality control. This has been used for a long time. Cameras could today take intricate pictures. Software can analyze that pictures, compare at least to patterns, make decisions on quality versus, defect, and so that type of a thing. So AI now becomes that big umbrella which has machine learning, deep learning, natural language processing. So the ML is machine learning, and we'll talk about each one of them in detail next. DL is deep learning, and NLP is natural language processing, and other subfields sit. We'll stop here. If there is any question, comment on this slide. Now we're going to get more deeper into these. We are talking about supply chain. We have a lot other. So which area are you thinking about? Oh, yes. There is a decision support systems in every functionality you can think of. For example, staffing, HR kind of things. There you have decision support systems. Marketing, customer sales kind of a thing, you have decision. Accounting today, accounting area has a decision support system for taxation and things of that. So every area has nuanced type of, any place where you would have this thing, right? Reasoning, decision making, perception, language understanding, those type of things, you could put those there. But we are restricting the healthcare supply chain management. Yeah. Only decision support systems are going to only tell you what to do. What are the consequences of doing? You still have the ability to say, I'm not going to do it. I'm going to do it differently. I don't think any organization has replaced that. It is, I call AI, in my opinion, augmented intelligence, not artificial intelligence. Human intelligence is the main. It gets augmented today. Each one of us have our own capability. To some extent, this has become a capability leveler. Right? Today, it's ChatGPT, if you think about it. You can type in the same question and you can type in the same question. Get something out of it. And how do you interpret and use this new individuals? So the leveler kind of a thing has started to happen. Information is power, they say. It should not be only with a few people. So now it has become a little bit more leveler. But the decision making still is human. Please don't give it up. Be smart in understanding these things, because you don't want people to tell you what these things are. Today, it's not that difficult. Just pay a little bit attention to what these things are. Or if a software is provided to you and gentlemen said they are interacting, try to understand the software in its totality. Remember the famous line that John F. Kennedy said, ask not what your country can do for you, but what you can do for your country. I will give you a different way of looking at technology. Ask not what you can do for technology, but what technology can do for you. It's the other way. Once you understand that, technology should be under you think, not you being in for the technology. Okay, next slide. Okay, let's spend some time on this. Each one of these slides, I'm going to take time. If you have questions, let's stop, okay? So, machine learning. So, the first one that we talked about, this is the workhorse of any AI. This is the workhorse. This works on your data. What does it do? It uses algorithms to learn patterns from data. That's what it does. Don't worry about what those algorithms are, whether Python coding was done. Those are all there. But basically algorithms, which are set of rules. Remember yesterday or day before when professor presented, she gave those different nodes and how many do you need to satisfy all the nodes, right? That's the kind of a problem. A lot of people said 3, 4, and 5, and then we would said with 2 locations you can satisfy everything. For which she went through an algorithm. She said, let's look at all the nodes, step by step, she said. That's all an algorithm is, kind of a heuristic. Sometimes the heuristic is driven mathematically. Sometimes the heuristic is driven exactly rules of thumb, how you do it. A recipe that you use in cooking might be very, things that have been perfected over time of steps. So things like that, algorithms are there. And supposing you present data to the algorithm, and if it's starting to learn patterns, okay, from data and make predictions or decisions without explicitly programmed for every scenario. This is where AI tools become interesting. They can take a minimum data and start extrapolating, which is why you have to be cautious also. Right? So, types of machine learning relevant to healthcare supply chain management, it's on the right side. When you see there, it talks, that table there has 4 types of learning, right? That table right there we see. One is called a supervised learning, which means you are providing the data and you are also providing the rules as to how these patterns have to be recognized. Example, in forecasting, there are 3 components, they say. If you look at a demand over time and present that to a software, 3 things happen. What are those 3 things? Number 1, it's an average behavior in the data. The overall, people are going to buy 20 units of this item. That's an average behavior. Second would be any trends that are happening. Suddenly social media is saying something and you're going buying whatever. Or a movie is running well and more people are word of mouth saying, so the second show versus the third show versus the next show, more people are, it's a trend happening. So do you capture that? So if over a period of time such trends are there in the data, then those trends have to be understood. So that's the second component on any time series kind of data. Third component is seasonality. So some of these patterns might occur only through a season, right? If you go to a retail shop, there may be a sale going on. Suddenly when you come to a Friday, Saturday, Sunday, it could form a season by itself, or at least Saturday, Sunday, whatever. Or your true seasons, right? A religious holiday, whatever it is, a true season that creates a pattern of sale. Or sometimes, as I said in PetSmart, it's after Christmas that people buy, and so it could go, the seasonality can extend beyond that particular season. So those are the 3 components, the average behavior, the trend behavior, and seasonal behavior. Now, a supervised learning is telling the computer, this is how I want you to identify average, trend, and seasonality. And then let loose the data into it. It will identify the pattern and it will tell if this is the kind of trend and seasonality, it can predict what the demand is going to be in the future. So that is an example of a very supervised type of a learning. Unsupervised is the completely opposite of it. You don't want to guide the computer to do anything. You want it to kind of discover. So a lot of different clusters can happen in inventory. So you want to discover those type of things. So that is patient segmentation. It's a very interesting area to look at. Depending on various kind of patients that you receive, how do you segment them to different categories so that you can allocate resources to them? Any fraud detection is a place you don't want to be using supervised learning because you may miss out on a fraud that you don't think it is. So the computer is trying to understand. Then you have reinforcement learning. That is, the rules have to be reinforced. Some constraints have to be reinforced over and over again. So that comes under the routing for ambulances type of thing. You know, they cannot vary from the route. Very important, but there are other things that are critical. So things of that kind. Then somewhere between supervised and unsupervised is your semi-supervised learning. When you are looking at customer comments and trying to make sense out of it, whether a patient comment or customer comments, and seeing how you relate it to any decision making, right? So processing where labeled data is scarce. So this is more word of mouth kind of data or some data that they have given us feedback, whether it is good or bad kind of feedback. And then it talks about various algorithms here just for your, completeness sake. cycle regression or decision trees or k-means clustering. These are all names of things that are already coded, which in order to use it rightly, you need to go through a training to see where to use them. Why ML works well for SEM? Because you have large volumes of transactional data. Every time an invoice is paid, every time an order is placed, these are all transactional. They're not transformational, right? They're transactions between two parties. So that data as it is captured is helpful. Ability to capture nonlinear relationships. X need not lead to Y all the time. X can lead to something else indirectly. So that type of a nonlinear relationship can also be captured by machine learning. And it learns continuously with new data. As you're feeding data to these things, they're keeping on learning. Example would be in demand forecasting, their error rates. This computer looks at the error rate and say, as new data comes in, how do I reduce the error rate? And there are a lot of techniques for doing that, so it'll try and do that. So I'm going to stop here and see, and I think it's a time to, if you think it's a time to take the break also. So hold on before the break. Any questions on this particular slide? Or the same data? Yes, you can. Probably you will start first with unsupervised learning if you don't know. Learn from it, and maybe then you may want to say, I want it more supervised now, or the other way. I think data is there. These are more of options. I would say to anyone who knows how to use the option, use all of them and see what happens. This is a digital learning for us.
Well, there.
Only thing is, if you have any unstructured data, the traditional things all work extremely well. And I would say, please go there first when you have structured data. Age, disease name, all the risk factors properly defined. We have epistemology data that is used with biostatistics a lot. There is no need to go to AI as a first place of contact. Unstructured data, imagery that comes in. This gentleman talked about mammography.
Yeah.
Very, very difficult to predict with certain types of models.
CNN there.
Yes. So that's where I would say. Alrighty. Not? Yes, please.
Something has to be told to the computer as to how we are going to segment. How do we do it unsupervised way?
So unsupervised, what it does is you let it choose the combination of things to cluster. Then you look at it and say, aha, I didn't think of these two together. Something interesting happening there. So to some extent, it's a discovery of data sets, which again is not your structured data. If there was unstructured data in it, things are there. And then the fourth column is customer comments. If they were thrown in, which you normally can't throw in to your structured modeling techniques, unless you codify them into binary or other variables. If the customer said this, it's a 0. They said something else, it's a 1. Then you could now structure that information. But the richness comes by what their emotion they conveyed, things of that kind. So now AI is able to look at that and use its algorithms to see, how do I cluster things? Would I cluster the same way? Good. Would I cluster differently? Why? It's a question for us to look at. Outbreaks, yes, that's where a lot of these things have come. Yeah. Okay.